Hi, my name is Muhammad Tariq, and in this lecture, we will explore the tree traversal. We have seen the insertion operation, we have seen the deletion operation, and now, if we want to display the nodes of the binary search tree, so we can use the traversal technique to display the nodes and the data of the binary search tree. So, let's get started. A binary tree is defined recursively. It consists of a root, a left subtree, and a right subtree. We already know this. To traverse or walk the binary tree is to visit each node in the tree exactly once. So the tree traversal or the word traverse is actually a walking. So we touch each nodes in the tree exactly once. Tree traversal are naturally recursive. Naturally it's recursive, but we can also use the iterative method to traverse the tree and to print that data using the iterative technique. So the pre-order traversal. We have three techniques: pre-order traversal, post-order traversal, and in-order traversal. So first we will look at the pre-order traversal. In pre-order traversal, the root is visited first and has a procedure. So it's a method, simple method, and we will talk about this later. In-order traversal. In-order traversal, the root is visited in the middle. So in order traversal, what happens? The root is first we print the left hand side node, then we print the root, and then we print the right hand side node. And this is a recursive method for in order traversal. In post order traversal, the root is visited last, and this is the simple method. Now, flags. We can use the flags to easily identify the traversal type. We can use the flags, and using these flags we can identify which type of traversal it is. For example, the order in which the nodes are visited during a tree traversal can be easily determined by imagining there is a flag attached to each node. Now, as you can see in pre-order, the direction of the flag is towards the left hand side. In order, the direction of the flag is towards the ground, and in post order the direction of the flag is towards the right hand side. Now, what is the benefit of attaching these flags to the nodes? Now the next picture will show you the benefit, and will show you the benefit of these flags. Now, as you can see, it's a sample tree, and here the flags are attached towards the left direction. Now what we will do is we will attach these flags, we will attach the nodes of these flags, and this will be the pre-order traversal. The result which we will get using this traversal will be the pre-order traversal. So as you can see, we have attached these nodes and we have printed the result A, B, D, E, C, F. So this is the pre-order traversal. In post-order traversal, the direction of the flags are towards ground, and we will attach these, so we will get the result which is the in-order traversal result. And in post-order traversal, we have the direction towards the right hand side, towards the right side, and we will attach all these, and we will get a different result. And I will show you its working, the recursive working of in-order traversal. As you can see here, I have a node. I have an IDE, the NetBeans IDE, on the left hand side, and I have a PowerPoint presentation on the right hand side. So this is a delete method. Let's collapse this. Now we'll implement the in order traversal. So this tree and the right hand side is a sample tree, and these are the nodes. I have inserted these nodes in the binary search tree, and this is a stack. I will also debug the code and show you the recursive calls of the traversal to make you better understand the flow of the code. So let's implement the code. Let's implement the in-order traversal. I am going to implement the in-order traversal for this video. Public void NORDER in order, and we'll take a node. Okay. Now let's first check if node is not equals to null. If it's not equals to null, then we will proceed. And what we will say is in order, and we will call node dot left. As you know that in order traversal, we first visit the left node, then we visit the middle node or the parent node, and then the last node, which is the left right hand side. First we will visit the left node. Recursive is the recursive call. I am actually calling this method again, and then we will print the data, actually data, sorry, node dot data, and then we will again make a recursive call to the right hand side, so this is a method which I have implemented, and I'll walk you through. I'll debug this code for you to make you understand the flow of recursive calls. So now let's call this method from here, bst dot in order, and here we will pass the root node, right? So we'll start with the root node. Now pay attention to these codes. Pay attention to the green bar that will show you the current position, and I'll use this tree here to show you the working and the pointers of the tree. Okay, let's debug this code. Okay, all right. So here this is the first line in which we are actually determining that if the node is null. So the first node we passed, so we pass the root node. Okay, so the first node will be 50. Let's use this stack. This is a sample stack. So the first method call, we know the method call goes to the stack, and the first method call will be I'm write only in. I will only write in to show the method name in order. Actually the name is in order, but I'll only write in. Okay, so the first is 50. In means in order, here is just a short form. So the first call to the method is 50, right? So if 50 is null, node number 50 is null. Okay. So let's check this. Let's check this. This is 50, right? Is 50 null? No, 50 is not null. Then we will execute. This line will be executed. This green line. Now the current pointer is on 108. This line, right? Pay attention to these line of code. Okay, so the node dot left, the left of 50 is 30. Now here the left of 50 is 30. So the next stack in the stack we will have a new frame with 30. This will be actually a method call. Okay, this in is only a short form for in order, the method we have here. Okay, this one. So here we are standing at this line, node dot left. So as you can see here, it's a method call. So the green line, the green pointer went to the if condition, because now we have called the in order again. We have called this method recursively. So now it's actually the pointer here. Our pointer is actually in this method with which having the node 30. Okay. So now let's check node dot left. So the node 30 dot left. Is node 30 having the left node? Yes, it has a left node which is 20. Let's add a new frame here, in, and it is 20. Okay, it is 20. Now this green line will go back again to line number 106, this line, because it's a recursive call. So as you saw, it went back to the first line. Now it will check, it's a null. No, it's not null. Now 20 dot left, it means the node number 20 dot left. Does 20 contains a left node? No, it doesn't contain. It's a null actually. So what will happen? So now left is node, as you see, null. You can see here the node is, the tooltip shows that this node is null. And if it's null, it will come out of this method. Now, as you saw, this is the last line of the method. It has came out, but it is still within the 20th node. Now it's printing the second line. As you saw, it has printed the first line. It's actually this one. Now it's printing the uh, node number 20, because there is no left node, so it came out. Now it's printing the first letter, the first node that will be printed. It will be 20. So let's write here 20. Okay. And now the right. Does it have a right node? Yes, it has a right node. Now as you see, it's a recursive call, and we have again no in, and we have now 22, right? So now we have 22. Is 22 null? No, it's not null. Does 22 contains a left node? Node dot left? No, it doesn't contain a left node. Now it's going again. Is it null? Yes, it is null. It will come out. Now it will print. Now you see it's in the in system.out.println line. Now it will print 20 because left node, this line has been, line number 106 has been executed. So the next node is 22, and this data will be printed here. So we have 22, right? Now does it have a right node? No, it doesn't have a right node. So this method call has been completed. So this method call has been completed. So we will remove this stack. This stack will be removed, right? Now it now the 20 has also been completed, because uh, the left node and the right node has been printed. So this has also been completed. Now our actual pointer is at 30, right? A pointer is at 30. So the stack value here is 30. So, and in 30, and as you remember, the first line has been executed, right? The first line has already been executed. Now it will come to the line number 109, this line, the line number 109, because the first line has already been executed when this method was called, right? So now you see it has come to this line, and it will print 30, right? It will print 30. So here we will write 30. Okay. Now node dot write. Now it's actually standing on the 30th node, and it's saying dot write. Does it have a right node? Yes, it has a right node, which is 45. It has a right node, which is 45. So here we see n 45. Now it will go back. Now in dot null, no, it's not null because it's actually standing at 45. Now node dot left. Does 45 has a left node? No, it doesn't have a left node, and it neither have the right node. So it's going back. It's null. Yes, it is null because there is no left node. We'll come back. Now it will point, or the execution pointer will come on line number 109, this line. As you see, now it will print 45, because we are doing the in order traversal. It first checked the left hand side node. It has checked, and the 45 does not have a left hand side node. Then it will print the middle node, which is 45. Now it will print the middle node, which is 45. Okay. Now it's going to check, does it have a right side node, or you can say the right hand side child. No, it doesn't have a right hand side child also. So it will come out. So now this node has been completed. Okay. So this will be removed from the stack. Okay. And 30 has also been completed. You see, we have completed this 20 number node and 45 number node also. So 30 has also been completed. Okay. And now 50. So you remember the first line number 108 has already been executed when it was first called. Now now the pointer is on line number 109, which is the system.out.println statement. Now it will print 50. Are you with me? Now it's printing 50. Okay. And now it will check the right hand side. It will come down. It will come down. It will check, does it have a right hand side node? Yes, it has a right hand side node. And is it null? No, it's not null. And so the node is 70, right? Node is 70. Now it will check the 70. Now is 70 null? No, it's not null. Now then it will go to the right hand side of, sorry, to the left hand side of 70, and then it's the same procedure that we did with the left subtree, right? With this subtree, uh, this one, the procedure I show with this one, this will be again repeated. So this is how the recursive calls keep the track of the data, and this is how the recursive calls work. So this was the in order traversal, and with the same way you can implement, or you can also understand the pre-order traversal and the post-order traversal. It's easy, it's not very complicated, and I hope you must have got an idea that how the pre in order traversal is working and how the recursive calls are working. I hope you must have learned something from this lecture, and I will see you in the next lecture. Thank you.